Hello students. Now we'll go move on to the next type of rock which I'll be talking about is sedimentary rocks. Now sedimentary rocks. We know that rocks made up of bits and pieces of other rocks. Sedimentary rocks forms when sediments, rocks made of bits and pieces of other rocks are pressed and cemented. In the previous class I had mentioned that they are pressed and cemented together, or when minerals form from solutions. Now, what are the sediments? Simple thing. What are sediments over here? They are small solid pieces of material that come from rocks or living things like bones, leaves, and stems. Again, what are these sediments? What we are talking about in sedimentary rocks? They are small solid pieces of material that come from rocks or living things like bones, leaves, and stems. Now, if I can tell you all more about sedimentary rocks, these rocks are formed by the deposition, or you can say cementation of sediments, cementing of sediments and deposition of these sediments on the earth's surface and within the water bodies. They are within the water bodies. The mineral and organic particles formed by the wearing of rocks from one area by rivers, wind, ice, or any other agent of change, and their subsequent deposition in new areas where they harden and get cemented. They are formed like that. The material lays down in layers. As I said, sediments basically they are in layers or strata. Sediments strata or layers. That's why it's named by another, it's called by another name also, that's called stratified rocks, because it's in layers or strata. So that is the thing. These are called sedimentary rocks. Now look at these different types of rocks we are seeing over here: sandstone, conglomerate, limestone, shale. These are examples of sedimentary rocks. Now basically sedimentary rocks also are of three types, students, if I can say. They are formed according to the manner of their formation, as in organically formed sedimentary rocks, which are organically formed. They are formed of the hard parts of animals, such as bones or shells. We all know that, as I described you all what is sediment. So they are formed from the animal bones and shells. These get cemented over a period of time and to make rocks which may have fossils in them. Example, if you look at it, it's limestone. So all limestone is particularly a rock which is organically formed. Now what is mechanically formed sedimentary rocks? Rock fragments are weathered, broken. They are weathered or broken, or they get disintegrated by agents of erosion. There are different agents of erosion carried over distances and then laid down in layers. Now, over the years, these mechanically formed sedimentary rocks, they get compacted and they get cemented to form rocks. Now, which are these mechanically formed rocks? You can say is sandstone. If you look at sandstone, this is mechanically formed. Organically formed is limestone. These are they may also form by the accumulation and hardening of they may also form by the accumulation of hardening of organic debris such as leaves, roots. See, in this definition, everything is defined. That's why I've defined sediments in particular, so that you'll understand how they are mechanically formed, organically formed, and collectively formed. They are formed by the accumulation and hardening of organic debris such as leaves, roots, other plants, and animal matter. Now, what happens is over here, these materials undergo change when they are buried in these swampy areas or the marshy areas to form black carbon rich rocks, which may be rich in fossil. Now, if you see, a good example would be coal. This is an important fuel source. Coal is an important fuel source. Liquid oil is also formed in this manner. So these all are organically formed. So if I give you an example of limestone, coal, all this is organically sedimentary rock. Now there's another type of formation of sedimentary rock, that is chemically formed sedimentary rocks. What do these include? They include those rocks which are made by chemical process. As the name says, they are chemically formed. So they include which are uh, processed chemically. The rocks are formed by direct chemical precipitation of mineral matter. Example, gypsum and salt. These accumulate in salt lakes and lagoons when the vapor evaporates. Over here, what happens if you take from that matter gypsum or salt? They accumulate in salt lakes and lagoons, where what happens is when water evaporates, there's some chemical transition happening, chemical process happening, and they're chemically formed sedimentary rocks. So these are the three types of sedimentary rocks which are formed. Then we move on to metamorphic rocks, the last one. Metamorphic rocks, igneous, as I said in my previous class, igneous rocks and sedimentary rocks put together form metamorphic rocks. Meta and morph means a change in form. Now, metamorphic rocks are made from sedimentary and igneous rocks. These rocks are formed when heat and pressure are added to igneous and sedimentary rocks. They go through immense pressure. This usually happens when mountains are made. So when does this happen? Usually when mountains are made. Metamorphic rocks, they are created by sedimentary and igneous rocks when put under extreme pressure or heat. Now, metamorphic rocks include slate made from shale, then anthracite coal made from bituminous coal, and genesis made from any rock. Over here, if I say they are literally metamorphic rocks, basically are literally changed rocks. They are also called as changed rocks. As sedimentary are called, what are they called? They are called stratified rocks because they are in layers and strata. Metamorphic rocks are called changed rocks because two rocks put together, when they go under immense pressure of heat, then they change into metamorphic rocks. Over here, metamorphose, it is derived from a word called metamorphose, which means change. Now over here, when primary and secondary is sedimentary rocks, primary is igneous rocks, they are subjected, they go over a total change. This changed rock is called metamorphic rocks because both the compositions and the formations are different and they undergo change. The heat and pressure that occurs may be due to some mountain building movement, volcanic, or some major earth movement. It could be due to any reasons. And as I said, like granite basically may change into genesis. Uh, Here, if I can give you all some examples, or you'll have done it in previous classes. Now, see the different examples: genesis, slate, quartzite, schist, marble, and phyllite. What is this now? Basically, granite changes into genesis. Basalt, a common example of exclusive igneous rocks, which I had given you all, that also changes into schists. Sandstone is a sedimentary rock which changes into quartzite. Then there's limestone, which is also another sedimentary rock which changes into marble. Marble is derived from, so the original rocks. Now suppose I'm again repeating this. Original rock was granite. A metamorphic rock, what we get from granite is genesis. An original rock is basalt. We get schist. Then original rock, what we get is sandstone. The metamorphic rock we get from sandstone is quartzite. The original sedimentary rock is limestone. What we derive from that a metamorphic rock is marble. Original rock is shale. What we derive from that as metamorphic rock is slate. Coal is original rock. And when a metamorphic rock is when they are actually metamorphic rock basically means they are metamorphosed, they are changed, and it becomes graphite. So this is the example of metamorphic rocks. Now if you look at this over here, they basically the igneous rock, uh, sedimentary rock and metamorphic rock is there. Over here, if you see, we spoke about igneous, they are intrusive and extrusive rocks, sedimentary rocks. They are mechanically formed. I gave an example of sandstone, chemically formed. Metamorphic rock is organically formed. Before I move on to weathering, what is basically the importance of rocks? If I need to understand that. Basically, rocks, they are of great importance. How they are of great importance? They are good as building material. They are used as building material. Soils are formed from rocks. Different soils are formed from rocks. Hence, the rock type determines the soil type. We get valuable minerals are found in igneous rocks and metamorphic rocks. Some of these minerals provide us with fuel resources, and fuel is very important for human or human purpose or economic purpose also, if you see. So valuable minerals are found in these rocks. They are used in industrial raw materials also. These rocks are used in industrial raw materials also. So the three kinds of rocks which I spoke to you all about was igneous, which is primary and parent rock, derived from the magma, and it's from these rocks different other rocks are derived. Then we spoke about the different classifications under igneous rocks, that's intrusive and extrusive. Intrusive is within, deep within. Extrusive is on the outer surface, earth's surface. Moving on to that, we moved on to sedimentary rocks. They are layered rocks. They are called stratified rocks because they are in layers or strata. Then sedimentary rocks also we spoke about how there are three types according to their manner or the formation, that is mechanically formed. Mechanically formed rock, I told you all an example of sandstone. Then there is organically formed sedimentary rocks, which I spoke about. I told you, gave you an example of limestone. Then the chemically formed is salt or gypsum. So these were the three types of sedimentary rocks we did. Then metamorphic rocks. Metamorphic rocks are also called chained rocks, changed rocks, because it's from the word metamorphose, which means change. Their formation and composition is changed totally. So that's why when they're subjected due to extreme heat and pressure. So the different types of metamorphic rocks and which sedimentary and igneous rocks, when they are metamorphosed, what do they become? There's a different new formation or a new rock which comes out completely. Now what we are going to study about is weathering. Now, as I gave you all a brief about importance or a brief about the types of rocks and importance of rocks, now we come to the main thing, that is weathering. Now, what is weathering? Weathering is the breaking down of rocks and other materials on the Earth's surface. The breakdown and fragmentation of rocks into particles or units. See over here how they are interlinked or how they are connected to one another. That's why you needed to know you needed basically to know what how rocks play an important role in weathering and how weathering is a part of rocks. So the breakdown and fragmentation of rocks into particles or units. Now what are the controlling factors of weathering over here? How they are interlinked, that's why I'm starting. Before I begin, just let's understand point wise what are the factors. We'll go in depth later, but controlling factors of weathering: composition and structure of rock, nature of ground slope, climatic variations, the floral effects. What are the agents of weathering? The wind, the glacier, the running water, sea waves, underground water. Now over here, if you'll understand, weathering leads to soil formation. There are three types of physical, chemical and biological weathering. This is what we're going to study in this chapter. The topography, climate, characteristics of rocks influence weathering. So that's how rock and weathering are related. They are connected to one another, and you all needed to know uh, what rocks are, how do they play an important role in weathering. Now weathering over here, if you see, when rocks break, the grains, when rocks break, the grains in the rocks get disintegrated. Disintegrated is like they break down further. This means that they get weakened, and over a period of time, they get eroded and break. What is weathering? As I said, it is a physical or a chemical breakdown due to weather conditions. Weathering means there's some weather condition playing an important role. It occurs mainly through the action of water, temperature on rocks, and the reaction of rocks on the processes, to these processes. As very little or no motion of material takes place in weathering, it is called in situ process. Why is it called an in situ process? Because there is no motion of materials, or there's very little motion of materials. Weathering often results in rounding and smoothing of sharp edges of rocks. Basically, it results in the smoothing of the edges of these rocks. So this is basically weathering. More so, what information what we can gather is like the earth's surface is constantly undergoing changes. Due to the internal and external forces, new landforms are being created. Agents of change or erosion are working on these landforms. Now they are carried over distances. If you see this erosion or this all gets carried over distances, and finally they are deposited in new places. In other words, if you say the earth's surface is remodeled, the remodeling is called gradation. Now what is gradation over here? If I talk about gradation, basically it comprises of a threefold process: degradation of erosion, the process of aggradation or deposition, and transportation. The process of degradation over here involves the lowering of surface of denudation. Weathering here, in simple terms, we'll put it as it's a process through which rocks are slowly broken down over a period of time. In simple terms, what is weathering? It is a process through which rocks are slowly broken down over a period of time. Now, weathering involves what? Decomposition, that is chemical decaying. Disintegration means physical breakdown. When we talk about disintegration, what does disintegration mean over here? Physical breakdown of rocks. Disintegration and decomposition. Chemical decay and physical breakdown basically. Disintegration and decomposition means chemical decay and physical breakdown of rocks are caused by the climatic and biological elements. So weathering leads to continuous loosening of rock and soil. Here weathering plays a very important role in loosening and uh, loosening of rock and soil. So here what happens is weathering makes the work of gradation easier. And what is gradation? Remodeling. Remodeling of the earth's surface. Regradation is remodeling. Moving further over here, there are different types of weather. Now here before this we'll try to understand what are the factors also which are important. Types of weathering. Types of weathering. The rocks are weathered physically or chemically. The rocks are weathered physically or chemically. So they are mm, there are two types of weathering: physical weathering and chemical weathering. Factors such as water, heat, and pressure, which affect weathering, can cause both the types of weathering, chemical and physical. So, chemical and physical can take place due to factors such as water, heat, and pressure. Both can take place, weathering. Effect of such factors can be varying on different rocks and different climates. Now, what are these factors which affect weathering? If you try and understand, water. Water is a Water is a common factor which plays an important role in weathering. This is the first factor which affects weathering. It plays an important role in weathering. The availability of water largely depends on the climate of the place. Definitely, climate also plays a pivotal role where availability of water is concerned. It enters the small pores, cracks, and fissures inside the rocks. We all know about these cracks and fissures, faulting, folding, and how the cracks and folds are formed. In areas where diurnal range of temperature is high, water inside the cracks freezes during nights. Now what happens over here? When the temperature is high, the water inside these cracks freezes during nights. During daytime, it again becomes water. When water freezes, its volume increases. Definitely the volume will increase. It starts exerting. Exerting pressure means putting pressure on the walls of the rock, and the cracks widen. The cracks grow even more further. Eventually, the rocks break down. This is how water plays a role in the weathering or breaking down of rocks. This process is called freeze and thaw weathering. Now, there could be a small question regarding what do you mean, explain freeze and thaw weathering. So you should be able to explain it. It is particularly effective in high altitudes or at high heights in mid and low latitudes, high latitudes, as well as mountainous regions. So in specific regions, it's pretty active if you all see. The sedimentary rocks such as sandstone, grit, and conglomerate, these are examples of sedimentary rocks. Stratified rocks, layered rocks, sedimentary rocks, they get easily disintegrated due to water. Disintegrated means break due to water. This is the freeze and thaw weathering figure, what you all can have a look at. Then next, what happens over here? Water also breaks down the rocks chemically. Now, how does water break down chemically? They have explained it in this paragraph. This can happen in two ways. Over here, the water molecules react with minerals. There are minerals present in rocks, we already know. These water molecules, they react chemically with the minerals already which are present in the rocks. This process is called hydrolysis. Now, what is hydrolysis? When water molecules react with minerals present in rocks. If the rock is made up of those minerals which react easily with water, the compounds of those elements will form and break the rock. So this is how the process takes place. This process can happen. Which kind of rocks it can happen with? This process can happen with those igneous rocks which have silicate minerals. If there are particular minerals known as silicate, then only this can happen. The resultant compounds, the result got down from these compounds will break the rock by changing the chemical composition. The whole composition changes chemically of these minerals in the rock after the hydrolysis. For physical and chemical weathering to happen, the water present as moisture in the soil or air is also enough to cause weathering. Now, for physical and chemical weathering to happen, the water present as moisture also means look at the importance or the relevance of water in weathering. That's why it is a factor of weathering, or it affects weathering. For physical and chemical weathering to happen, the water present as moisture in the soil or air is also enough to cause weathering. Another way by which water can cause chemical weathering is by solution. Now, this is another way how it can cause chemical weathering is by solution. Now, over here, what happens when some minerals in the rock, when some minerals in the rock get when some minerals in the rock react with water in the rock or moisture in the air and get dissolved, the process is called solution. In the first phase we studied what was hydrolysis, how hydrolysis plays an important role. In the second part we are going to study is about solution. What is the solution here? What happens? Chemical weathering by solution. What happens over here? When some minerals in the rock react with water in the rock or moisture in the air and get dissolved in the process is called solution. They form acids, get leached from the main rock and lead to decomposition over here. So basically when we talk about decomposition, I've already told you what decomposition means. So they form acids and they lead to decomposition. Now what kind of minerals dissolve in water? Calcium, magnesium, nitrates dissolve in water. For example, the calcium. Now here they've given an example of a mineral called calcium, which is present in limestone. It reacts with water and air to form carbonic acid. See, there's a chemical formation happening over here, students. That's carbonic acid. The minerals dissolve in water and get carried away in water. They get carried away in water. The second thing what they are talking about here is like oxygen, carbon dioxide and salt and all they will talk about. So over here oxygen. Now oxygen in the air and water reacts with certain elements and minerals inside the rock. What happens? Oxygen is there in the air. This and water react with certain elements and the minerals which are already present in the rock. So you all can understand over here that when we spoke about in this class, in this lecture was what is weathering? Basically, weathering is breaking down of rocks. It can cause weathering can cause both types of water, heat, and pressure can affect weathering and cause both type of weathering, that is chemical and physical weathering. It basically results in smoothing or the sharp edges of rocks. And what else did we cover in this lesson is when there is no motion of materials or very little of motion of materials in weathering, it is called in situ process. It is a physical, weathering is simple terms, physical or chemical breakdown due to weather conditions. In weathering, what happens when rocks break? They get disintegrated. The first factor here what we learned was which affects weathering is water. Water is a common factor. It largely depends on the climate. What happens in the first place is it enters, to sum it up, it enters into the small pores, cracks and fissures inside the rock. During night it freezes and the volume increases. During daytime again it becomes water. Now when water freezes, we know that the volume increases. This puts pressure and cracks are formed and they are widened. Eventually what happens? The rocks break down. This process is called freeze and thaw weathering. So students, there are different definitions which can come for the exam related to weathering. that is in situ process, as I said, freeze and thaw weathering. Then second thing what they're talking about is hydrolysis, where water breaks down in, chemically in two ways, that is through hydrolysis and by solution. In hydrolysis, what happens is the water molecules react with minerals present in the rocks. So when they react, the molecules, water molecules, when they react with minerals in the rocks, it is called hydrolysis. Okay. So the last and not the least, we learned is chemical weathering, which is by solution, another way. In this, what happens when some minerals in the rock react with water in the rock or moisture in the air and get dissolved? They form acid and lead to decomposition of rocks. Minerals like magnesium, calcium, nitrates dissolve in water. And they give an example how chemical weathering is through by solution. So this is all what we have covered, and we are going to move on and try to understand how carbon dioxide plays an important role, how oxygen plays an important role, salt, then heat also, how does that play an important role, which are the other factors like pressure, everything, and then we'll move on to the different types.